All right, classify the following variables as categorical or numerical. The outcome of the next football game.
Categorical.
Yes.
Oh my God. I found my ID.
Categorical. All right, number 1B. Hush. The distance a golf ball travels. Numerical. Numerical. The time it takes to swim. Hush. The time it takes to swim 100 meters. Numerical. The results of the next at bat in a baseball game. Categorical. All right. Problem 2 says to describe the shape of the data. So shape, you have a couple of options. You have skewed. Then you have skewed right. Form. Yes.
I have DeAndre Sullivan for early release.
Yes, you may. After you have these 4 main types, you have 2 other possibilities that it could be a mix of. I'm just writing the different types it could be, and then we're going to label which one's which. Alright, so those are the different types of distributions we can have. So now we are labeling which one's which. To tell the difference, Trey, between skewed left and skewed right, where the lower part of the data is the direction of the skew. So this one, where's the small part of it? On the right. So this one is skewed right.
So like, okay, so that, because then all that stuff, since it's like over here, it's high at the top over here,
Mhm.
So what was, the next one's on the other
right, and then the other one is on the right or the left.
Yes. Okay. So the next one, this one, what do you think it's going to be? Symmetrical.
It does not have to be exact.
No, it does not have to be exact. It has to be really, really close.
The uniform is when it's in the middle.
Is that one right there? So why is it the first one on the bottom?
Uniform, because symmetrical is if I fold it in half, it's going to look the same. If I fold this graph in half, does it look really, really close to being the same? Then it's symmetrical.
All right, what's that one?
What do you think this one might be?
Uniform. Symmetrical. I don't know.
I would say it's slightly symmetrical.
It was fun though.
Right.
What's up, bud?
He has to be that loud. He doesn't know how to be quiet.
Oh, you got
Okay. On the last graph. On the last graph.
I know. It's probably hotter out there than.
On the last graph. Does it look symmetrical? Does it look symmetrical? No. Hey.
Y'all hush.
He was
Uniform
Okay.
was where all of the bars are exactly the same. Are they all exactly the same? No. Bimodal means there's two heels.
Well, unimodal is one.
Okay, it is unimodal.
Slightly symmetrical.
It's not symmetrical because if I fold that in half, it's not going to look the same.
Right there. It's not even noticeable. Slightly.
But it is also something else. Tay and Jay, hush. Hush. Why do you say it's skewed right?
All the stuff's on the left.
Yep. Skewed.
It could be two.
Mhm.
Well, it's gonna be two on one part.
You're just going to have to list one. You're just going to have to list one.
Oh, okay.
All right, so it's unimodal and it's skewed right. It's both. What do you think this one might be?
It could be two humps, right?
Mhm.
Bimodal.
Bimodal. This one could also be bimodal.
Hey, you got a little bull stuff on your dick?
Smart trick.
December 18th.
Smart.
All right, number 3. Number 3, here are the passing yardage totals for the New York Giants quarterback, Eli Manning, for each of his 16 games during the 2008 regular season. Sketch a dot plot to show that Manning's distribution of passing yards. When I'm sketching a dot plot, I first want to ask myself, what is my smallest number and what's my biggest number?
305 and 190.
Okay, 305 and 119.
Yeah.
So I have to make sure my dot plot covers from 119 to 305. I would start it at 115.
What did you do about 5?
That's going to be a lot. I know.
Like 20.
I know. I think 5 would be too much or too small.
That is awesome.
You can do about 20. I was going to do about 15s. But you can go by 20s.
What if I did it by like 50? I started at 0, 50, 1. I just did it like. Would you take any way that like?
Mhm.
It was me. I did it. Please.
The out numbers. Wait, is it voice recording?
I'll take forever.
That's your I'm holding this. It's recording my voice.
What? You must have turned it in.
Mm-mm.
Gotta be like construction.
Let me see that. I mean, that's how I do it.
She's not gonna be here.
That's the cost. The one I did was.
Yeah, just like 100, 150.
I did like
I'll
50,
say.
100, 200, 250.
95, 100, 310.
Weird.
All right, so that's my dot plot. I counted by 15s. You could have counted by something bigger or smaller. It does not matter. So now I have to do a dot plot. I'm going to put a point on my graph for every number I see. 216. So I'm going to go to 216 on my graph and put a point. So it's going to be about somewhere right here. Uh-huh. I'm going by 15s. I said 5s were too small. 260. 289. 267. 196. 161. 199. 147. 191. Here's the thing, the study guide should already been completed because you had 2 days to work on it. 153. 240. 305. I'm going to move when I get done. 123. 191. 181. And 119. So there's my dot plot. Yeah. Mhm. Okay. The next part of this question says to find the mean and median. How do I find the mean? Add them all up.
Well, see, you should already have it, so go over and write it down.
All right, so mean, you add all the numbers together. So what do you get when you add them all together? You see if anyone agrees or disagrees with you. But I want the total. I don't want it before you divide. I want it before you divide, not after.
We both want to do like so.
$32, $38. Brooke got $32, $38. Someone needs to agree or disagree with her.
I agree. Disagree.
What'd you get?
You're not a productive citizen, Connor. All right, just staring at it and
Hmm? I don't remember what she got.
What did she say she got?
32, 38. All right. So once you add them all together, you should have gotten 32, 38. The next step is to divide by the number of items.
16.
So you're going to divide by 16.
And then you get 12.
So that the mean is what? 202.38.
Okay, so here's give me 2 seconds to gather my thoughts.
I just gave you little side notes to find the mean.
Oh, wait, no.
You got it?
Yeah, I was trying to figure out how you got 2,238, but then I added one.
Okay.
Hey, how much does this thing worth?
Hmm? I think it's like 15 or 20. All right, that was a mean. To find the median, what's my first step to finding the median? Put numbers in order.
Yeah, then you gotta see which one is new, right?
So what's my smallest number?
119.
What's the next one?
123. 147. 150. 161. 181. 191. 191.
One what?
91. We're still
Okay.
196. 199. 216. 240. 260. 267. 289. 305.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so here is our 16 numbers. To find the median, you first have to put the numbers in order. Once you put them in order, you're going to cross out numbers on the ends until you reach the middle.
There's two numbers in the middle. So you add them and divide it by 2, right?
Yep. So when you cross them out, you should have gotten
191 and 196.
2, 3, 1, 2, 3, 2, 2, 2, 2. I just did it the quick way. Okay. So you said that I get 2 numbers in the middle. When I have 2 numbers in the middle, you add them together. Thank you. And you do what?
You add it and then divide by it. And then you get and then divide by 2.
So what was it again? I moved up. What were my 2 numbers?
So 191 and
196. All right. So if you get 2 numbers in the middle, you add them together. Thank you.
Man, this is
Thank you.
emergency. What, you want some money?
The phone.
You get the phone.
All right. So if 2 numbers are in the middle, you're going to add them together. What's 196? 191 plus 196.
and divide by 2. 193.5. I need some lead. Okay, I'll just give you a pencil.
Then divide by 2. What's 387 divided by 2?
193.5.
193.5 is our median.
Yeah.
So 193.5. So that's how you do the next one. So let's go to the next page. Guys.
It's almost.
Okay.
I really don't think it'd be hard.
Do Okay, number 4. Do noise crowds in the Metrodome help the Minnesota Vikings play better defense? Here are the points allowed at home and on the road. State the hypothesis we're interested in testing. So our first hypothesis is the null hypothesis.
The Minnesota Vikings have the same ability to play defense on the road and at home.
Good job, Brooke. The Minnesota's MN, right?
Yeah. That's it.
Vikings.
Oh, I don't know. I lied to you. I don't know.
What's the plural of hypothesis?
Yes.
Hypotheses. So there'd be 2 E's.
You know, plural of
No, that's the plural.
That's the plural.
I like that.
The singular has IS instead of ES.
Oh.
All right, the Minnesota Vikings have the same ability to play defense
Dang, I'm so happy.
at home and on the road or away.
This is what I need to figure out how to find the difference. The difference of means just the literal, like you subtract the means of each one. Yeah. Same thing with means.
We'll get there in a minute. All right. The null hypothesis is that the Minnesota Vikings have the same ability to play defense at home and on the road.
Correct.
The alternative hypothesis
They have at home, then on
the Minnesota Vikings have
a higher.
a greater or higher ability
Play defense at home.
to play defense at home than on the road. Okay. For the last two chapters, we've talked about two different things. We talked about finding the difference of means and the mean difference. Or the difference of means, the difference of medians, and the mean difference. Okay? To find the difference of means, you find the mean of this and the mean of this. So mean of points allowed at home.
You ever do unpaired data?
This is unpaired data. There is, but the steps that we're taking right now is doing unpaired. It would be better, but the question doesn't ask for unpaired data yet. So the difference of means. Find the mean of points allowed at home. So you're going to add this whole column up. So add the column up. Okay? So you get 143 when you add them all up. And then how many numbers did we have? How many? 8. So do 143 divided by 8. 17.87.
I got it. 17.87.
Okay. Remember, we're doing the difference of means. So I'm finding the means of both columns. Now find the mean of the points allowed on the road. Okay, so Brooke got 190 as the total. And you're going to divide by what? So what's 190 divided by 8? Okay. Because we said our null hypothesis was that they would do better on home, we're going to do home minus road. So you're going to do 17.87 and subtract 23.75. This is your difference of means. It also has another name. This would be your test statistic. So difference of means or your test statistic. When it's asked for the difference of medians, you're going to do the same thing, except instead of using mean, you're going to use median.
We'll just do the same thing.
Okay? So to do medians, what's my first step? Veronica knows this one. What's my first step? Put them in order. So and what? 27? Okay. So what two numbers are in the middle? So 18 and 19. Add them up, divide by 2, and you get what?
18.5.
Finding the difference of medians. So, allowed on at road or at home. So finding the median of points allowed on the road. Put them in order.
30.
So what two numbers are in the middle? 19 and 24. Add them up, divide by 2, what do you get?
Wait.
We're really moving fast today. I tell you
I
what.
know, right? I can't even keep
Love it.
up.
I love it. Keep moving fast.
Wait.
Keep rolling.
Do you have a question?
Wait, no, I just gotta write this down. That's it.
Okay, so the median of home was 18.5 and the median of road was 21.5. So now subtract them. Home minus road, so it's going to be 18.5 minus 21.5. What do you get?
Well, you only have to do all those steps on the first.
Does it have to be in that order of home and on the road?
Home minus road, yes.
Can you do the other one?
Road minus home? You'll get a positive 3, so it'd be wrong. You're always going to do whatever context you think they're going to do better in. You do that first and subtract the other one. So 90% of the time, you're going to think a team does better at home than on the road, right? So it's always just going to be home minus road. There again, this could also be a test statistic. So if it says find the test statistic, you could find this one. What do you mean? Why do you not understand? It depends. Like, it would say find the test statistic using medians. You would use medians. Find the test statistic of means. This is the test statistic. Yes. It will tell you which one to find. Y'all hush. Hush. Okay. Does using fuel additive help cars, NASCARs, go further between fill-ups? Suppose that you can use 20 NASCARs and 20 drivers in an experiment to investigate this question. What are the explanatory and response variables? The explanatory is what you're changing between its tests. So for this one, the fuel additive. The response variable is your outcome or what you're looking to see what happens. So for this one, it's going to be the distance between fill-ups. The distance between fill-ups. Okay. Most of the time, your treatments is going to be the same as your explanatory variable. So what is the treatment? The fuel additive.
What does BW mean?
Between.
That's easy.
Okay. C. How do you incorporate randomization in your experiments? Randomly select cars to receive the fuel additive. What variables would it be important to control during this experiment? Type of weather, car, track. It's not really like one that you really want to say because it's NASCAR is in there. But if I said no, they'll be on and make a big deal about it. Type of driver. Speed.
Oh, yeah.
Okay. Can drivers be blind in this experiment? No. Yes. I don't remember telling you now.
No, because they know when they're stopping. So they know when they're getting the fuel out.
But it's not when they're stopping. Okay, well then I made a mistake. Okay. The drivers can be blind because do they have to be the people to put the fuel in their car? No. So they can be blind. If you tell me that they cannot be blind because they need to see to drive, get with the program. Get with the program. Okay? So yes, they can be blind. Why is this important? This doesn't, guys, when it asks why is this important, this doesn't mean how can they be blind. They want to know why is this important. Why is being blind important?
So they don't change the way they drive because the car.
So they don't become biased. So they don't become biased. Or they don't change the way they drive. So they don't change the way they drive. I'm about to move some other people if they do not stop talking. Okay. $45. It's ringing now. Testing's over. SLOs for government, I think, or economics or something. In track, sprinters typically use starting blocks because they think it will help them run faster. Is this true? To test this hypothesis, an experiment was designed where each sprinter on a track team ran a 50-meter dash 2 times, once using starting blocks and once using a standing start. The order of the 2 different types of starts was randomly determined at random for each sprinter. You know how you were asking earlier about plural and singular? IS is singular. Bentley, I'm sorry. I thought it was you, Dylan.
Yeah.
Where over here,
Even though you say it's
well, this is hypotheses, and the other one's hypothesis. All right. Here again. Hush. Number A, 6A. What are the explanatory variables? What are you changing with this experiment? Depends on how much longer we have. Okay. If the explanatory variable is what's being changed, what is the response variable? Time it takes to run 50-meter dash. Is this paired or unpaired data? Okay, so here it says because they think it will help them run faster. So therefore, running faster means we're trying to get there quicker. Faster is time. When the other example up here, it was go further. Further indicates distance. Does that make sense, Dwayne? All right. So is this paired or unpaired data? Paired. Why? Because each sprinter uses both. Because each sprinter uses both starting block and standing.
So what I said, okay, how you have the one person comparing two things, is that okay? I said I enjoyed it.
Oh, this fixing to scroll back down. Okay, so this is paired data because each sprinter is using both objects, the standing block or the starting block and just standing.
Why do they just do
Because they feel like they think it will make them get there faster.
Get a better jump.
I ain't never used it.
Well, I think they make it to where it's stable. Like, it's not just laid there.
Yeah.
All right. What forms of control should be used in this experiment?
The same type of people.
You got it right.
Same people.
This is the same.
Everyone should run the same distance.
The type of shoes. Where they're
Okay. Whoop, time out. Why do you think shoes is important?
Not. They could be just like Veronica shoes, and then they could be like track.
Mhm. So it's important that they wear the same shoes, because it's not fair if I wear flip-flops on one run and wear tennis shoes in the next. So track. It's not fair if you have one person running on grass and then the other one running on concrete. Shin splints hurt. Anything else that you can think of? Okay. How was randomization incorporated?
Because is it randomized when they're blind to it, when they don't know?
Can they be blind on this one though?
Oh no, that was one. Why'd you take that whole thing?
I'll tell you in a minute. The what?
You could random and you could randomly select which person
Randomly select which starting position they use first. So randomly select which starting position they use first. Were they blind? No. Because they could tell if they used a starting block or not. Okay, so this is a good stopping point. Does anyone need to see any of the questions again?